Okay, so today we're going to talk about the area of shapes on the coordinate plane, and you still are going to need to use the distance formula that we've been using. Or some of you noticed that the book let you be using the Pythagorean theorem to find distance and drawing up the right triangle on the graph. That's an acceptable way to do this as well. So if you're comfortable with the Pythagorean theorem way, you can do that. You will still need your midpoint formula. And you will still need your slope formula because we're going to use several things where the lines have to be perpendicular. So you must verify that the slopes are opposite and reciprocal. For instance, something that looks like this. And the symbol here that I just drew means perpendicular. Those slopes are opposite, so one's positive, one's negative, and reciprocal, which means the fractions are flipped. So you're going to need those formulas. And I'm going to go through a couple area formulas. So area of a rectangle, length times width. Hopefully everybody knows that. A square, the length and width are the same. So you just plug in the same number for both of them. A triangle, 1/2 base times height. Some of you might know this is base times height divided by 2. The key to base and height is they must be perpendicular. It means nothing else other than they're perpendicular. And call this the base and this the height. If you twist a little bit, you can see that base can sit on the bottom. You can twist the area and twist the shape around however you want, and the area will not change. So areas of a triangle can also have a base that's outside, or a height that's outside the triangle. Again, it's perpendicular, but it could be the extended version of the line. For a parallelogram, we're just going to do base times height. And a parallelogram is two sets of parallel sides. We've kind of talked about that. And these little arrows indicate parallel. And this. So we've got base and height. And my last area formula is the trapezoid. Trapezoid is one set of parallel sides. And so we're going to do 1/2 the base on the two bases. Essentially, the first part here is average the two bases. So for my trapezoid, height up here, doesn't really matter which base is longer, but there's my two bases. I'm going to put one on the graph. Go for the trapezoid. So I have this trapezoid. Now I don't exactly have grids on here. My height is right here. And I don't really need to use the distance formula for this. Now, there's a possibility I might have to sometimes, because they might not be going horizontally. When I'm going horizontally and vertically, this height is just going vertically. It's going from 1 to 4. That's 3. Base 1 goes from -3 to 5. That's got a length of 8. Base 2 goes from, oops, I missed a negative sign. -1 to 4. That's got a length of 5. So to find the area, I use my formula, 1/2. So I'll write the formula right above it. It's not the equal sign. 1/2 b1 plus b2 times the height. And yes, I'm just implying the multiply there. Base 1, so I'm now going to fill it in. Base 1 is 8. Base 2 is 5. Height is 3. You can feel free to use a calculator on this, or do it by hand. 8 plus 5 is 13. Now you can multiply by 1/2, or multiply by 3. Half of 39 is 8. I'm not given a unit. Area is always in square units. So since I'm not given a unit, I'm going to say U for units. And because area has 2 dimensions, I use units that are the shape of squares. So I call them either U by U, or square units, or abbreviated with units squared. Okay, that's today's lesson.